Bismillahirrahmanirrahim. Let's start this course, which is heat and mass transfer, the code of which is ME315. I am Mubashir Ali Siddiqui, and Alhamdulillah I am serving as professor in Mechanical Engineering Department of NED University of Engineering and Technology. The books that we would be following in this course, or rather the book that we would be following in this course is the Fundamentals of Heat and Mass Transfer by written by these four gentlemen. However, it is more renowned by the name of the last two authors, Incoropera and Dewitt. You can get its the latest edition which is available out there is its 8th edition. However, you can get hold of either 7th or 8th. Even if you get 7th, that is more than good. The reference book that you might need to refer many times is the Heat and Mass Transfer Fundamentals and Applications, written by these two authors, Yunus Sinjal and Afshin Ghajar. This is a book which you would like to refer to various times because it has a lot of detailed information. But the reference book or the textbook, the textbook that we would be using in this course is the one which is on top, Fundamentals of Heat and Mass Transfer by Incoropera and Dewitt. These are the topics that we would be covering in the specified time. In fact, we would be learning the three modes of heat transfer, namely conduction, convection and radiation. So we would be learning the basics of or the fundamentals of the three modes of heat transfer in the first week, and which is there in chapter number 1 of our book. And then after chapter number 1 we would be learning conduction in detail. For example, in chapters 2, 3 and 5. So these are the three chapters that focus more towards conduction, and then we would have a couple of chapters on radiation, and then the rest belong to 6, 7, 8, 9 and 10 belong to convection majorly. And now when we say that chapters 2, 3 and 5 are the conduction chapters, that does not mean that that the problems over there do not involve convection and radiation. They do involve convection and radiation, but convection and radiation would be dealt with at minimum level. The more focus would be on the advanced studies in conduction. Similarly, for example, when we say chapter 6, 7, 8 and 9 focus on convection, so they would be focusing on convection more, and the conduction and radiation would be at its very basic level. A very important chapter number 11 would be in line, which is about the heat exchangers, about the designing of heat exchangers, and then the last chapter would be the one in which we would be learning the mass transfer. So in fact, before we start, I would like to emphasize an important thing. There is a myth, and the myth is that the heat transfer course is a very difficult course. I do not agree with this myth, with this statement. The thing is that it is a very interesting course, and it is not difficult course. It is not difficult at all. However, there are a lot of topics. For example, you can see over here that we have conduction, right? And then we have got radiation, and then we have got boundary layer analysis, we have got forced convection, we have got free convection, we have got heat exchanger, we have got mass transfer. So there are various topics, and we need to keep track of those topics. It is a very, very important course. It is a very basic. Does not mean basic in nature. Basic means in terms of application, because there you will hardly find any final year project which does not involve this the application of heat transfer. Almost all the final year projects which are related to energy domain do use the heat transfer and thermodynamics. So do not think it as a difficult course. It is a very easy course, and it is a very interesting course. All you need to do is spare a couple of hours or rather 3 hours every week, so that you can go with the pace of the class, or you can go ahead of the pace of the class. Now the course learning outcomes, there are 4 course learning outcomes that are listed over there. The first one is regarding the modes of heat transfer, and then the second one is regarding the convection and the analogy between the convection and mass transfer, and then the third course learning outcome is regarding the heat exchangers. The fourth one is regarding the labs. As usual, there would be 40 session marks, and that would consist of either midterm or assignment or quiz or complex engineering problem, CEP. But the midterm and assignment, I mean, that would depend with the course of the time how the things change in this particular situation. The final exam is as usual, or would be as usual, worth 60 marks. Okay, now let's start with this comparison between thermodynamics and heat transfer. All of you have undertaken a course on thermodynamics in first year of engineering. Now the thing is that are the two courses the same? Are thermodynamics and heat transfer the same courses? Because therm can be translated as heat, and dynamics means something which is in motion, which is being transferred. So can we take the two courses as the same? The answer is in fact no. Thermodynamics and heat transfer are not the same courses. Rather, thermodynamics deals with the amount of heat transfer. As a system undergoes a process from one equilibrium state to another equilibrium state, and it makes no reference as to how long the process will take. So for example, if the process is a heat transfer process, and the initial state is 1 and the final state is 2, and if the process takes, for example, 20 minutes, so you can find out the total heat going into or out of the system during those 20 minutes. So that would be the domain of thermodynamics. But if you are asked to find out the heat that would go into or come out of the system in, for example, 7 minutes, so that would be under the domain of heat transfer. So what is the difference is that in heat transfer we are interested in the rate of heat transfer, time rate of heat transfer in fact. So thermodynamics deals with equilibrium states and changes from one equilibrium state to the other, right? So from the start of the process till the end of the process. And the thermodynamic analysis would give us how much, the amount of heat, again the amount of heat, how much heat would be transferred into the system or out of the system. So for example, if there is, let's take an example in which there is a thermos bottle having a hot fluid inside, and let's say it cools down from 90 degrees Celsius to 80 degrees Celsius. So if we want to find out that how long it will take, the process will take to cool it down from 90 degrees Celsius to 80 degrees Celsius, in order to determine that, we need the rates of heat transfer. Means we need to have expressions in time. So that would be the domain of heat transfer. If we simply want to find out how much heat in total would come out of the system if it is cooled down from 90 to 80, so that would be the domain of thermodynamics. So thermodynamics deals with the amount of heat transfer, whereas heat transfer deals with the rates of heat transfer. So the time domain comes under heat transfer. Just a very quick review of what was heat. Of course, all of you would be very well aware of this fact that heat is in fact a form of energy that can be transferred from one system to another system or from a system to its surrounding as a result of temperature difference. As a result of temperature difference, or what we say by virtue of temperature difference. Now what does this mean is that if there are two systems, say A and B, and suppose that A is at a higher temperature, say 100 degrees Celsius, and B is at a lower temperature, for example 30 degrees Celsius. So A being at higher temperature would be having higher energy content, and that energy would move from higher temperature body, means from A to B, and as a result of this energy transfer, the temperature of A will reduce and the temperature of B will gain, because the heat which is leaving A is being gained by B. So the temperature of body B will, or the energy content of body B will increase, will go up, as a result of which the temperature of body B will go up, will increase, and this energy traffic will keep on going till both the bodies attain the same temperature. So let's say if both the bodies attain 50 degrees Celsius, so then this energy transfer will no more exist. So the point is that the energy which was being transferred from A to B, from higher temperature body to lower temperature body, was mainly because of that temperature difference. And when that temperature difference did not exist, the energy transfer did not take place. So that energy transfer was taking place due to temperature difference, and the energy which is being transferred due to temperature difference is what we call heat. So heat is the energy in transition. In fact, it cannot be contained in a body. What we contain in a body is energy, and not the heat or work. So that was a quick overview of heat.